Testing 1, 2. Okay, welcome. While we're waiting for more people to slowly come in, right, I see some messages in the chat already. Right, hi Greece and hi Bhushan. For those of you who are here already, how well do you think you did on the competition? Do you think you did well? Or do you think you did average? Or maybe not as well as you wanted? Okay, we'll just wait maybe 1 or 2 minutes more for some people to join. And then we'll start very, very soon. So just give us one more moment. Hi, Brendan. Okay, I think maybe it is about time. We should begin now. Right. For anyone who join later, then they should join later. Okay, so we can just start first without that. Okay, so let us begin. For this question number one here, what they want us to do is calculate the following expression given to us. Now, this expression looks a little bit scary, right? Because we don't really see anything that's going on within the numerator or maybe the denominator. But there is something that we can notice about this though. In the past, when we solve such questions, what do we do? Right, let's say we have been given a question of 1 over 2 plus 1 over 6 plus 1 over 12 and so on. What's the trick there? The trick there is to take your difference of fractions, right? We do what is called telescopic. We split 1 over 1 minus half and so on. 1 over 2 minus 1 over 3, 1 over 3 minus 1 over 4, and so on. And that will allow us to easily calculate the terms in the sequence. Now, currently, we don't really know what to do with the numbers 24, 40, 60, and so on, because we don't really see the relationship between 2, 6, 12, 20, so on. But if you write down more numbers, then you'll start to see a pattern of what is going on with the question and our example here. You will notice that the number 24 is going to be exactly 2 times of 12. The number 40 is going to be exactly 2 times of 20. The number 60 is going to be exactly twice of 30. And 84 will be 2 times of 42. So if you manage to notice such a pattern, then you can see that the result of this will be, I can first start by dividing by 2. So I can write down 504. Okay? So I take out 504 from every single one of these numbers. Then the first one will be a 2 over 24, which is a 1 over 12. The next one will be a 2 over 20. Sorry, 2 over 40, that's a 1 over 20. And then I have a 2 over 60, that's equals to 1 over 30. Right? And then I have the next one, right? 1 over 42 and so on. Then you can see that the numbers here, they look like what I have for our example. Right? Now, what will be the very last number? The very last number here, we can take out 504, we get a 2 over 264 left over, that's equals to 1 over 132. And that will be 11 times 12. So that means I can write down 504 And then 1 over 12 is 1 over 3 minus 1 over 4. 1 over 20 is 1 over 4 minus 1 over 5. Next one, we have 1 over 5 minus 1 over 6. Right, 1 over 6 minus 1 over 7. All the way until my very last number. That's going to be a value of 1 over 11 minus 1 over 12. Okay, so when we write it in this way, then you can see I can cancel out a lot of terms in my expression. Right, cancel out minus 1 over 4 plus 1 over 4 minus 1 over 5 plus 1 over 5 and so on so forth. And then I'm realizing that I have 1 over 3 minus away 1 over 12 left over in my expression. So here you can actually calculate 1 over 3 minus 1 over 12. That's equals to 1 over 4. So it's 504 times 1 over 4. Okay. So if you divide this by 4, then you get exactly 126 as your answer. Okay, after every single question, I'll pause for maybe 1 or 2 minutes just to see if there's any questions that you would like to ask. If not, then we can actually continue on with the next question. Huh? Okay, let's take a look at this question number 2. Question number 2 tells you this. There are 25 students whose sum of scores is equals to 2025 and no two students have the same score. If the highest score among them is 94, what's the value of the lowest score? So if I want one of them to have the lowest possible score, then what must I do? So this situation is a situation where we have some number, right, plus some number plus so on and so forth, all the way until 94. This is 2025. If I want the first number here to be small, that means I want everything else to be big, right? So if I want everything else to be big, then what should I let the numbers be? I should let the numbers be 93, 92, 91, 90, all the way down, right? Okay, then what should the first number in this group of numbers that we have in red color, what should that be? Well, we notice that there are 25 students in total, right? So we want to start from 94 and then we want to minus away 24. This is to get to the first student and we add 1. Therefore, this thing here will be equals to a value of 71. So therefore, the very last possibility here will be the number 71. There, right here. Okay? And then this will be my last 24 numbers. So now, what is my small number? My small number here will be equals to 2025 minus 71, 72, all the way until 94. And we know that there are a total of 24 numbers here. So we can think of it as 12 pairs. Each pair is 71 plus 94. Right. So we're going to calculate out what this is equals to. 71 plus 94, let's do it at the side. That's equals to 165. And now if I multiply by 12, I can get a value of 1980. So therefore, this will be 2025 minus 1980, 45. So in this case, the lowest possible score will be equals to 45. Okay, that's the answer for question 2. Now, let me move on to question number 3. Question number 3, we have 4 people A, B, C, D. They know how many marbles each of them has and each states a statement as shown below. Ah, and then if only one of them is lying, who is lying? Ah, so A says, I have neither the most nor the least. B says, I have not the least. And then C says, I have the most. And D says, I have the least. So out of them, 3 are telling the truth. Right? So you have 3 truth and 1 lie. So what you can do is just to think, okay, what happens if they are lying, right? Or who is lying in that case? Let's take a look at the situations here. The first case is when A is lying. If A is lying, then what happens? If A is lying, then A has either the most or the least. And if A has either the most or the least, then we know, okay, that means that C or D is lying. And we know that it's not possible, right? Because we cannot have 2 people who are lying at the same time. Okay, let's consider what happens if B is lying. If B is lying, then everyone else must be telling the truth. If B is lying, everyone else must be telling the truth. But that is a contradiction. Because if B is lying, then it means that B is the least. And that is contradicting with with D saying that D has the least. So it means that D is lying. So we also know this is not possible. Okay. What happens if C is lying? If C is lying, then we know, okay, in this case, C is not the most, but then D has the least, right? D is the least. Okay? C is not the most, and then B is also not the least, and then A is not most nor least. So here at the moment, it is not possible to find a contradiction. Actually, it means that this case is actually possible, right? For example, how do you do it in this case? It's just from most to least. Let me draw our table for you. Okay. So we let D be the least, right? We let B be the most. Okay. And then either C or A can be in the middle, right? So for example, B, A, C, D is a possibility. So in that case, it satisfies all 4 conditions. Finally, for the case if D is lying, then what happens? Then D is not the least, right? And what that means is that no one is the least because A is not the least, B is not the least, C is the most, and D is also not the least. So then it's a contradiction again because there must be someone that is the least. So together, from this conclusion of the question, we know that C must be the one that's lying. Okay, let's move on to question number 4. Right. Question number 4 says this thing. You have 5 times 7 cubed times 35. And this can be written as x to the power of y. What is the minimum value of x plus y? So let's try to factorize it. 35 is equals to 5 times 7. So together, there's a 5 times 5. This will be a 5 squared. Then the other part is a 7 cubed times 7. This will be a 7 to the power of 4. So how many ways are there to write it? Now, of course, I can think of it as 5 squared times 7 to the power of 4, this number to the power of 1. Right? So here my x will be this 5 squared times 7 to the power of 4. But in this case, your x and y, are they going to be big or are they going to be small? X is going to be very big, right? X is going to be 5 squared times 7 power 4. That's a very big number. So this is going to be too big of a sum. I don't really want this case to happen. Now, in that case, maybe I can try something else. Maybe I can try, since I know that 2 and 4 are both even numbers, I can try to rewrite it as 5 times 7 squared, then squared. In this case, I will see that they actually have a smaller sum. Because my number x is not as big as this 5 squared times 7 power 4 anymore. It is just this 5 times 7 squared that we have over here. So in this case, it is what we want. And there's no other possible cases because for any other possible cases, the powers must be factors of 2 and 4. So factors of 2 and 4, the only ones are 1 and 2, as we saw over here. So together, that tells us that in this question, the minimum value of x plus y will be this 5 times 7 squared. 5 times 7 squared is equals to 245. Okay? And then plus the number 2, right? Y is 2. So the answer is 247. Okay? For our next question, question number 5. We want to find the number of trailing zeros for this 1 times 2 times 3 times 4 times 5 around to 2025. So trailing zeros just means the number of ending zeros, how many zeros it has at its back. And the trick for such questions is we always want to count how many fives there are. Because to make a zero, we need to have a multiple of 10, right? And to have a multiple of 10, we need to have a 2 times 5. So we know that if I have more fives than twos, then it's the twos that's going to be the trouble. Right? If you have more twos than fives, then it's 5 that's going to be the one that is the trouble that you want to count. And in this case, there's definitely more twos than fives because there's more multiples of 2 and more powers multiples of 4 as well, right? Compared to 25 and so on. So how many fives are there? Well, in this case, we can start by looking at multiples of 5. Multiples of 5 here, what we have is going to be 2025 divided by 5, that's equals to 405. Then next we can ask how many multiples of 25. For this, we can just take 405 divided by 5, that's equals to 81. In the same way, multiples of 125, I can take this 81 and then divide by 5. But here I will have to actually round it down because 81 is not a perfect multiple of 5. So if you round it down, I can give you a value of 16. Then next I have a multiple of 625. So I take 16 divided by 5, I round it down again. So we can get the value of 3. And finally, if I'm asking for a multiple of the next one, 5 times 625, that's 3,125. That's way too big. I'm not going to get anything here. So therefore, if I look at the total multiples of 5, 25, 125, and 625, there's going to be 405 plus 81 plus 16 plus 3 equals to 505. And that will be the answer for this question. Okay. Before I move on to question number 6, let me change something. The last number is actually not this number here. The last number given in the contest is actually 1025 times 2025 over 446 plus 223 squared. Huh? So I'm sorry about that. Okay, let's take a look at this question number 6 here. Question number 6, they give you again something that looks like a bunch of fractions that you want to add up together. How do you do it? Actually, you do it in basically the same way as you did question number 1, using this difference of fractions. So what does it mean? If you take a look at the denominators, the first one, 410 plus 205 squared. That's 2 times of 205 together with 205 times of 205. So that's 205 times 207. Okay. If I take a look at the next group of numbers, 414 plus 207 squared, we can see it's basically the same idea here. Right? It's 2 times of 207 with 207 times of 207. So that's 207 times 209. And so if I continue on this way, we can see all the way until the last number, there is a pattern. We have this 446, right, plus 223 squared. You can see that this is 2 times of 223 with 223 times of it. So it's 223 times 225. So every single one of these fractions look like this. Now, if every one of them looks like that, can I find a general way to write 1 over n times n plus 2? Right, since everything looks like this. Turns out we can. Because if you try to do 1 over n minus 1 over n plus 2, you can see that the numerator will actually be 2 instead of 1. So that means we just need to add a half in front, and then these two expressions will be the same. So what that means is that if I'm trying to find this expression, let me first take out 1025 times 2025. The remaining part of this thing will be, you can take out additional half as well, right? Because every single thing will contain half. And then what you have is, the first one is 1 over 205 minus, 1 over 207. Then next one I have 1 over 207 minus 1 over 209, all the way until the very last one here, where we have 1 over, okay, this is 223 minus 1 over 225. Huh? Okay, so when at the end of this calculation, you can see that the middle terms can manage to cancel each other out. And then I'm just left with the first term and the last term of 1 over 205 minus away this 1 over 225. Okay, do I want to calculate this difference of fractions directly? The answer is no, because we can actually do something with the values of 1025 and 2025 outside. Right, if you notice, the value 1025 is actually going to be 5 times 205. And then the value of 2025 is actually a multiple of 225. It is equals to 9 times 225. Right, so they choose these numbers very specifically to let us cancel out with the denominator. Okay, so together with that, and then I have a times half at the back, I can try to see what this expression simplifies to. Huh? So the very first one I can cancel out the 205 with the 1 over 205. So the very first one becomes 5 times 9 times 225 times half. And then the second one becomes what? The second one becomes, if you try to do the calculation here, the 1 over 225 can cancel out with the 225, so the second one becomes 5 times 9 times 205 times half. And I want to subtract the two of them. And you can see the only bit of difference within these two expressions is the 225, right, minus away the 205. So that will be a difference of 20, right? So this is a 5 times 9 times 20, right, times a half. And therefore, 20 times a half is 10. This is equals to 450 as the final answer. Okay, let's continue on to the next question. Question number 7. The side length of the square is equals to 8 centimeters. Find the fraction of the shaded area to the square. Now, this question is actually quite challenging. If any of you here managed to get this question, yeah, you should feel proud of yourself, because this question uses an idea that is not so obvious at first. What this idea will use is the idea of similar triangles. Yeah. So similar triangles basically are triangles with the same shape but of different sizes. So here you can see that if I'm highlighting a certain shape on the diagram, let me do that. So I'll be highlighting the triangle here on top. Then within this triangle, the extra parallel line actually creates a similar triangle in this question. Yeah. So if I try to draw it out according to the diagram I have on the top left, what you can see is that this value is 2, and because the entire side length is 8, that this is equal to 6. Okay, now that actually tells you about something. That actually tells you about the relationship of the areas of these two. Right? You know that the side ratio of the small triangle to the big triangle is going to be 6 to 8, which is going to be 3 to 4. So what would be the area ratio if they are similar? The answer is that it will be 3 squared to 4 squared. 3 squared to 4 squared is going to be 9 units to 16 units as the area. And so what that means is that if I draw back on the diagram, I can relabel this part as 9 units, this part as 16 units minus 9 units, which is 7 units. And in the same way, I can go and label out every single thing on the diagram. So this one will be 9 units, 7 units, 9 units, 7 units, 9 units, and 7 units. And now, we actually don't know the shaded area, right? So how do I find that? The trick is to look at one particular triangle. For example, if I try to highlight on the diagram, let's say I'm taking a look at this particular triangle on the bottom left. We know exactly how big this triangle is supposed to be. Right? This triangle is actually going to be 16 plus 9, that's 25 units. And these 25 units in this green shape here, you notice that the side ratio is going to be a 3 to 1. So this is going to be 3 over 4 of half a square, right? Because it will be 3 over 4 of this particular shape over here in purple color. Okay, I see a question in the chat. Why 7u and 9u? So the 7u comes from 16 minus 9. So if you imagine on the left side, the entire triangle has area of 16. Right? Then I minus off the first part that is 9. Then 16 minus 9 will give you a value of 7. Okay, let me continue. It will be 3 over 4 times of half of the square. Okay? So 3 over 4 times half of the square. What does that mean? It means that the square itself will be 8 over 3 times of 25 units. That's equals to 200 over 3 units. And now I can subtract everything to find the shaded, right? I can subtract everything. The shaded here will be the entire square, which is 200 over 3 units, minus off the 97979797, right? So it's 200 over 3 minus 4 times of 16. That's 64. So if you take 200 over 3 minus 64, this is the same as 200 minus 192 over 3. This is equals to 8 over 3 units. And what we can see from here is that this 8 over 3 units compared to the entire square, which is 200 over 3, the fraction will be equals to what? Comparing these two, we can see the fraction is 8 over 200, which is equals to 1 over 25. Right? That is the final answer for this question. Okay, let me move on to question number 8. Question number 8, we have this angle ACD is 35 degrees, angle AGB is 6 degrees. We have two straight lines that are perpendicular to each other, right? ADG and CDE, and lines B and CF are equal in length. So let me draw out these two in the color so that you can see they are equal in length. Uh, Wait, sorry. Actually, it should be this and this. I made a mistake. BE and CF. Yeah. Okay. So BE and CF are equal in length. And I want to use that to find this angle CEF. Let me try to do that. See if I can. So the question becomes, how can we solve such a question? So what we can do for this question is that this condition of B equals to CF is something that's a little bit tricky, right, to use. We don't really know how to use this condition of B equals to CF. Wait, let me see. Um, just give me a moment here because I think that the problem condition is actually incorrect. Let me just see. I don't think it's supposed to be B and CF are equal. Anyone who has taken the competition, can you confirm it is B equals to CF, or was the competition question BG equals to EF? Can anyone confirm if it's one way or the other one? Okay, I just went to confirm. I believe the question condition is supposed to be the two red lines are equal in length and not the two blue ones. Okay, so sorry about that. Let me change the question. So actually it's supposed to be lines BG and not CF but EF are equal in length. Okay, so find this angle CF given to us. Now, for a question with these two lengths being equal, the condition is a very weird one to use, right? Because we are not very sure how to use this question where you have two lengths that equal to each other in the current state. Now, if you're not really sure how to equate these two lengths, then maybe you want to find certain kinds of triangles which uses one or two of these lengths, right? Currently, I can see, okay, there's a right angle triangle that uses this red color length here. There's another right angle triangle that uses this red color length. But they are not really related to each other. Yeah. So then we can take, okay, is there any triangle that can use both of the red lengths? Well, answer is not right now. Right, right now we cannot really use both of them. But what we can do is that we can slide one of the triangles somewhere. Slide one triangle somewhere so that it makes sense for us to use condition. So what I'm going to do here is that we can move, for example, the line BG. So this length BG, I'll move it downwards. And I'll move it downwards, I'll slide this length downwards until it is right here. Now the purpose of sliding downwards is so that I want to use the condition where this length and the other length are the same. And so let me slide the length downwards here. Then I'll connect the triangle given to us. Okay, so this is what it looks like. Now, there are some things that we do know when we do this sliding procedure. We do know something. We do know that because of our sliding, that the length of BE that slide downwards is the same as the length of G to this point that I don't really know. Okay, let's give this point a name. Let's call this point point P. So these two are the same. And BE from the question statement itself is also the same as AD. Okay, so all these three in light blue color are the same. And what that means on this diagram is actually we know something else. We know that the angle here at the bottom must also be an angle of 35 degrees, right? Because it is the same shape as the one on top, right? So the one on top here and the one at the bottom here, they are actually the same shape. Then what else do we know? We know something about this angle of 6 degrees, right? This angle of 6 degrees, it goes where? Because of the parallel condition, it goes here. So this tiny angle here is an angle of 6 degrees. And the angle beside this 6 degrees, we also know it will be equals to 90 minus away 35 degrees. So the angle beside here will be 55 degrees. Okay, so this is our situation. Now, what we can do here is that we can take a look at this triangle here, EPF. This is the most important triangle in the question. And this is the most important triangle in the question because we know that BG and EF are the same. So when I shift it downwards, the lines that are the same are these two. These two highlighted lines are the same. And if these two highlighted lines are the same, then the angle of 66 degrees at the point, okay, let me draw it out. The angle of 66 degrees at the point P must be the same 66 degrees at the point F. So then we know that in that case, okay, I have a value of 66 minus 35, which is equals to 26 degrees here. And we're done. Because these 26 degrees on the diagram, okay, if I remove the highlighter, this 26 degrees on the diagram is also equals to 26 degrees of the angle that you want to find. Okay, it's a little bit hard to see, but that's the 26 degrees. Yeah. So this question, the key thing is, we started off by drawing extra line shifted downwards because I want to be able to use the condition that the EF is equals to EP. And by shifting downwards, we can use the condition once you figure out the angle at the bottom is 66 degrees. Okay, let me move on to question number 9. Question number 9 here. Question number 9 is a very standard this area finding question. For students here at Math Training Center, you should be very familiar with this kind of questions if you have seen them before, especially if you are P6 students. Right? If you're not a P6 student yet, then maybe you haven't quite seen this before. So here we have a square with the area being 2025. That means that the side length is 45 and 45. And then DF is equals to 36. Find the area of the shaded region. What we're going to do for this question is we're going to take this big 45 by 45 upside down quadrant. I'm actually going to add it to the 36 by 36 quadrant as well. Why we want to add that? Because that's the only way to get these two curves. And after I add these two, then turns out there's only one thing I need to do, which is to subtract away the rectangle here where it is a 36 by 45. That's it. This is the only thing that I need to do within this question. How does this make sense? Well, if you try to take a look on the diagram, let me shade it out for you. The first one here, let me use, for example, maybe green color. So the first one here in green color is this area. Okay. Then the second one that I have, the right side up quadrant. Let me maybe use blue color. Is this one. Right. So what do you notice about this green and the blue color that I've colored? Firstly, they cover the entire rectangle. They cover the entire rectangle of your AEDF. So let me remove the areas within this rectangle. If I remove the areas within this rectangle, you can see, okay, the first part of the green color is gone. So then I remove those things at the top. So here I can just remove all these things. Okay, it looks a bit weird, but just give me a moment now while I remove them. Then after that, after I remove this, I can also remove everything at the bottom. Right, remove everything at the bottom. Then what's left over is basically the region that's in between. And then the region in between, actually, the green plus the blue, we need to remove one copy of it. Alright, so let's say that we remove the copy of blue color. Uh, let's say I remove the copy of blue color, then I'm only left with the green color inside. Okay, and then I can only left with the green color on the right side as well, the one that's formed by this region on the right. Okay, so that's why this will actually look like the correct shape. Yeah, now let me remove all of that. So we can just find these two quadrants add up together minus away the purple colored rectangle. Okay, so let's try to calculate. Taking pi as 3, the values for the question will be, first one, we have a 1/4 of a pi times 45 squared, that's the diameter, minus away 1/4 of pi times 36 squared. Okay, this is what we have. Then minus away the, sorry, this is a plus, I just realized. This is not minus, this is meant to be a plus. Then minus away the rectangle, which is a 45 times 36. And then with that, I can find out the answer. So this one here can be a little bit tedious. For example, here what we have is, this is 3 over 4 times 2025. This is a pi times 18 squared. That's going to be 3 times 18 squared. Minus of 45 times 36. So here this is 90 times 18. 90 times 18 is 1620. And at the end of this calculation here, you will be able to get the answer of 870 and 3 over 4 as the answer. Okay, let's move on to question number 10. Question number 10 is not an easy question. In fact, it can be quite tricky. Question number 10 says, there are a total of 100 red, green, blue, and yellow. The ratio of blue to green is 5 to 1. And then green will evenly divide the amount of red. So red is a multiple of green. After 134 blue marbles are added, the ratio of blue to red is 9 to 1. How many marbles are there? The key observation for this question is actually a little bit hard to see. It is the fact that the blue marbles, when you add 134, is a multiple of 9. This is the key observation for this question. And it seems like some condition that you won't really think of on your own, right? Because you probably think, okay, blue to green is 5 to 1, I need to use that. Or maybe green is a factor of red, I want to use that. Or maybe blue to red is 9 to 1, I want to use that. But turns out it is actually this condition. 5 units plus 134 is a multiple of 19. It's a multiple of 9. So 134 divided by 9 is remainder 1. It is remainder 8. So actually it's the same thing as 5 units minus 1 is a multiple of 9. So in that case, what can 1 unit be equals to? The first case is 1 unit equals to 2. Right, because 5 times 2 minus 1 is a multiple of 9. 1 unit can also be equals to 11. 5 times 11 minus 1 is a multiple of 9. 1 unit can also be equals to 20, right? 20 times 5 minus 1 is a multiple of 9. So in each of these cases, I can go and count how many are green, how many are blue, how many are red, how many are yellow. Okay, so let's count. So in the case where 1 unit is 2, 11, or 20, let's draw a table. In the first case, if 1 unit is equals to 2, then what's the green? If 1 unit is equals to 2, then the green one here will be equals to, sorry, let's start with blue. Blue is 5 units, right? Blue will be 10. Actually, no, green is 1 unit, green is just 2, right? So blue will be 5 times of 2, blue will be 10. Then once you add 134, blue will be 144 now. 144 divided by 9 is 16. So red is 16. So this thing here seems like it makes sense. Because red is 16, green is 2. Red is a multiple of green, right? So green will evenly divide the amount of red marbles. Okay, so seems like it makes sense. Now if you try green to be 11, Blue will be 5 times of 11, that's 55. And red will be just 55 plus 134, 189 divide by uh divide by 9. So that's equals to 21. So suddenly you can see, in this case, green is no longer a factor of red, right? Now in the last case, let's say 1 unit is equals to 20. Then in this case, blue will be 5 times of 20 minus 1. Blue will really be, blue will just be 5 times of 20, which is 100. We know that this is immediately impossible because there's more than 100 here. So the second case is impossible because 21 is not multiple of 11. The last case is impossible because you have more than 100 marbles. So it must be the first case. So green must be 2, blue must be 10, red must be 16. And that means that yellow will be 100 minus 2 minus 10 minus 16. This will be equals to 72. For our next question, number 11. Again, for this question, if you're a student here at Math Training Center, you have seen this question many times before. So this question should be doable within maybe 30 seconds for you. The trick for this question is to label the values given to us. So what we can do here is that we can label this thing as A and this thing as B. Then our expression will be of the form 1 plus A times B minus away. You can see that the second expression, this one here will be equals to 1 plus B. And then the last one will be equals to A. So I'm subtracting 1 plus B times of A. This is B plus AB minus away A minus away AB. So the plus AB and the minus AB can cancel out. You can just get B minus A, which is equals to 2023 over 2025. That is the answer. Okay. Next question, number 12. We have an 8-digit phone number. 85A32B63 is divisible by 99. Find the value of 11A plus 9B. So divisible by 99, again, there will be two conditions. Divisible by 9 is the sum of digits. So in this case, it will be 8, 5, 3, 2, 6, 3, and then A and B, right? Okay. Here, notice that 6 plus 3 is a multiple of 9, so you can immediately ignore that because 6 plus 3 is divisible by 9. Then in front, 18 is also a multiple of 9, so you can ignore that. So actually what it means is that A plus B is divisible by 9. Here there are two possible cases. Is either A plus B is equals to 9 or A plus B is equals to 18. Right? Notice that second case is only possible when both digits are 9. So probably it's going to be the first case, right? For the condition of divisible by 11, what I have is, again, we're going to do the same thing, but we do the alternating sum and digits. So 3 plus B plus 3 plus 5 minus away the other group here. 6 plus 2 plus 6. Sorry, plus A plus 8. Here you can notice again, 3 plus 5 is equals to 8. So cancel that out. You get 3 plus B minus 8 minus A. So actually it's going to be B minus A minus 5. It's actually a multiple of 11. So that means B minus A is equals to 5. Or is there any other case here? Turns out there is some other case. The other case will be equals to A minus B equals to 6. Sorry, or rather negative 6. So these are the two cases that we can have. Wait, sorry, I made a mistake. The other case, B minus A equals to negative 6. But now, which one will work? The idea is that A plus B and A minus B are either both odd or both even. Because they differ by exactly 2A, right? So in this case, if A plus B is 18, They are both 9 and 9. Can it be that b minus a is negative 6 in that case? No, cannot. Right? So immediately we know this case is not possible. Because in this case, you need a equals to b equals to 9. But if you put inside here, nope, that's not true. So the case we want is a plus b equals to 9 and b minus a equals to 5. Here we can add them up to get 2b is 14. So b must be 7. And from here, a is equals to 2. So 11a plus 9b is equals to the value of 22 plus 63. This is equals to 85. Okay, let's move on to question number 13. A three-digit number is such a digit in the tens place is the average of all the digits. How many such numbers are there? So this one requires us to do some listing. If the tens digit is the average of all digits, then actually the tens digit is just the average of the units place and the hundreds place. So what we can do is that we're going to do this question by looking at how many possibilities are in this case, where the tens is the average of the units and hundreds. Huh? If the tens digit is a 1, okay, firstly, can tens digit be a 0? Cannot, right? Because if tens digit is a 0, it must be 0, 0, 0, but that's not a three-digit number. If a tens digit is a 1, then it's only going to be 1, 1, 1 or 2, 1, 0. If the tens digit is a 2, then it's going to be 1, 2, 3, 2, 2, 2, 3, 2, 1, 4, 2, 0. So there are now 4 possibilities. If the mixed digit is a 3, same way, 1, 3, 5, 2, 3, 4, 3, 3, 3, 4, 3, 2, 5, 3, 1, and then 6, 3, 0. So there are 6 possibilities now. Right. So for number 4, you can see what's going on already. It will be 1, 4, 7 all the way down to 8, 4, 0. So there are going to be 8 possibilities. What about the number 5? There's 1, 5, 9. But what's the last case here? The last case here is actually going to be 9, 5, 1, right? Because we cannot have 10 as a digit. So far we have seen there are 2 cases here, there are 4 cases here, there are 6 cases here, 8 here, and then 9, right? But not 10. If I continue on to the number 7 in the 10th digit, then how many do we have? Then you can see that in this case, I'll start with, no, sorry, not 7, 6. I don't know why I skipped that. If I start with 6 in the digit here, then the first one I can try will be actually not starting with 2 anymore. The first one I try with starting with 3. 3, 6, 9, all the way to 9, 6, 3. Yeah? So there are 5 of them here. Then 7 will be 5, 7, 9, all the way until 9, 7, 5. Right. So there are 7 here, there are 5 here, and then 8, you have 7, 8, 9, 8, 8, 8, 9, 8, 7, and finally at 9, you have 9, 9, 9. So by listing out all the cases here, we can see actually the sum is just going to be the sum of all these red numbers, which is 1 plus 2 plus 3 all the way to 9. There are exactly 45 such numbers in this question. For question number 14, we have this thing here, right, where we have some kind of expression on top minus another expression versus some kind of expression below minus another expression. Let's start with the one at the bottom. The one at the bottom is in fact easier to find. And the reason why it's easy is because we can regroup the numbers. For the bottom, we can do 3 minus 2, 5 minus 4, 7 minus 6, and so on all the way until the last number, which is equals to 2025 minus 2024. So these are things that you can have. And you can notice that each one of them is equals to 1, right? 1, 1, 1, 1, all the way 1. How many ones do you have? You have as many ones as a number of even numbers there are. How many even numbers are there? There are 2024 divided by 2. There are 1012 even numbers, right? So it tells you there will be 1012 pairs. Okay, so now you know the denominator is exactly going to be 1012. And with that out of the way, we can do our numerator. So our numerator, I can actually also regroup that. In the same way I regroup my denominator. So for the top, I can do 3 squared minus 2 squared. And then 5 squared minus 4 squared. And then 7 squared minus 6 squared. All the way until 2025 squared minus 2024 squared. Right. So then the numerator is this thing. Here I can write it as 3 minus 2 times 3 plus 2. So here we're using a squared minus b squared is a minus b times a plus b. And then we have 5 minus 4 times 5 plus 4. 7 minus 6 times 7 plus 6. All the way until the very last one where you have 2025 minus 2024 times 2025 plus 2024. So the nice thing is that all these 3 minus 2, 5 minus 4, 7 minus 6, all the way until 2025 minus 2024, they are all 1. So this is just this term, this term, this term, or then this term, right? So that's going to be 2 plus 3 plus 4 plus 5 plus 6 plus 7. So notice when I write down the numbers here, I actually change the order a little bit. Within the sum just now, I write the bigger number here, smaller number behind. But now that I write the numbers, I write a small one in front, big number behind. And this is easy to add. This will be just the first number plus the last number divide by 2 times how many numbers there are. Right, times how many numbers there are. How many numbers are there? There are exactly 2024 numbers. So this one here will be 2027 times 1012. Then suddenly, we immediately have our answer here. We know that the answer for this question is 2027 times 1012 over 1012. So it is 2027. For our next question, question number 15. A number is formed starting with 1, 1, 2, 2, 3, 3, and so on. What is the 2025th digit? So how do I do this question? The way we can do this question is to understand. Okay. Uh, wait, I just realized starting. Okay. The way to do this question is to have some kind of understanding. When we have such a question, there's a certain formula that we need to know how we can do this thing. So the way to do this is 1 plus 2 plus 3 plus 163 is equals to 216. Remember this. So this is a fact that I want you to try to remember after today. And this fact is very important because what this fact tells you is that the value, right, the pattern goes like this: 1, 2, 2, right, 3, 3, 3, 4, 4, 4, 4, until the last one here, which is going to be 63 copies of 63. Right, 63, 63, 63, and 63. 63 of them. And if I look at all these things here, then there's exactly going to be 2016 numbers given to us. Right? 2016 numbers given to us. But here there's a mistake here. If you try to do it that way. What's the mistake if you do it this way? The mistake that you do it this way is that you're not looking at the 2025 number, you're looking at 2025 digit. So this fact, even though it's useful, but in this situation, it is not quite the same. Right? It's not quite the same because some number they use 2 digits instead of just having 1 digit. So in that case, what can we do? We can pretty much do the same thing, in fact, right? But we have to be a little more careful this time. So let me restart this thing here. But now what I want to do is I want to consider what happens until the number 10, right? What happens until number 10? Okay, so in fact, what happens until number 9? So there's going to be 9 copies of 9, right? So far we have 45 digits. But what happens from 10 onwards? From 10, I have 10 times of 10, right? All the way until something. So each of them have a 2 digit, right? And how many would it be? So if you try to calculate out, let's try to randomly guess a number. Randomly guess a number. you run roughly 2000 digits more, right? If I run roughly 2000 digits more, maybe I want roughly 1000 numbers. So if I want roughly 1000 numbers, then a reasonable guess would be to guess maybe 10 to all the way until 40, right? So let's guess 10 all the way until, let's say I have 40, 40, and then 40 copies of it. So how many digits would this be? You can see that in this case here, there will be 10 plus 11 plus 12 all the way until 40 times 2 number of digits, right? Because each one of them will occur this many number of times. So then the sum, 10 all the way to 40 is going to be 50. Then there are a total of 31 divided by 2. There are 31 numbers here, then we divide by 2. This is equals to 25 times 31, which is good enough, but not quite what we want, right? Not quite what we want. Okay, so then you can continue to guess the next step. You continue to guess the next step. Wait, let me just check through my calculations to make sure I didn't make a mistake. But yeah, wait, sorry, there's a times 2 here. So actually the 2 and the 2 cancel each other out. I made a mistake here. This is actually just 50 times 31, which is equals to 1550. Okay. So we still need more. Right. So you still need more. Then what do we need after you use the 41s? How many are there? There's going to be 2 times 41 equals to 82 digits. Is it enough? Not quite. If I use the 42s, there will be 2 times 42 equals to 84 digits. Is that enough again? Not quite. If I have 43, I can continue to do the same thing, 86 digits. And then if I have 44, I have a total of 88 digits over here. And then at 45, I have a total of 90 digits. So if I take a look at what happens when we add up to 45, right? I start with this 1550, I add 82, 84, 86, 88, and 90. I can see that this 1550 plus 86 times 5, 1550 plus this thing which is equals to 430. Yeah, 430 over here. This will give you 1980. Yeah. So this is so far going to be 1980. And then let's take the next one. Actually, no, we don't need to take the next one anymore because I started out with what? I started out with 45 digits, right? I started with 45 digits. This is from the 1-digit case. And then everything here I did so far was from a 2-digit case. So if I have my 1-digit case being 45, and if I have my 2-digit case being 1980, what does it mean? It means that so far together, we have actually exactly 2025. So interesting enough, the 2025 digit is actually just the ending of this pattern up to the number 45 exactly. So since these 2025 digits, what we want is the last digit in the sequence. And the last digit in the sequence is the number from the number 45 that we use. The last digit here that we use so far is the number 5. And that is the answer for this question. Okay, that's the answer for this question. Now, we only have 5 more questions left over. Let's continue. Question number 16. This is a very confusing question because of all the words in the question. It says someone has 42 marbles and give away a prime number x amount of marbles and is left with a prime number amount of marbles. So 42 minus a prime number x is equal to some other prime. Let's call it p. Then p plus a y number of marbles is equals to another prime. So let's call it q. Right? Then q minus z is going to be some other number of marbles and is left with a non-zero amount. So this thing here, q minus z has to be at least 0. So these are the conditions given, where we have p, q, x, y, z are all prime. Now the thing I actually want to start with is the second situation here. If you have a prime plus another prime equals to another prime, when can this happen? Now, of course, it could be that P is 2, Y is 3, and Q is 5, right? But if P is 2, then it's actually not possible because X is 40. The only way this can happen otherwise is that Y is 2. Because you don't want an odd number plus odd number to be odd number. That means the only possible case is where you have odd number plus even number is an odd number. So that gives you Y must be equals to 2. Right? Because just now we confirmed P cannot be 2, huh? So Y must be 2. And Y is 2, then we call this thing twin primes. So what that means is that the prime numbers here, they must come in a pair. So if we list out the twin primes from 1 all the way to 42, we can realize 3, 5 is a group of twin primes, 5, 7 is a group of twin primes, 9 is not, 11, 13, 17, 19, right? 21 is not prime, 23, 25 is not prime, 27, no, 29 and 31. Then 33 is not prime, 35 is not prime, 37 is, but 39 is not prime. So therefore, these are the groups of twin primes. So let's check how many of them work here. Again, we can try to draw our table. So if P, Q, if P is 3, Q is 5, what is X? X is 39. So, we immediately know this is not possible, right? Because 39 is not prime. If P is 5 and Q is 7, then X is 42 minus 5 is 37. Yeah, this is good. Yeah, this is what we want. Then same thing, we can do the rest. If P is 11, X is 31. Okay, no problem. Right? If P is 17, X is 42 minus 17, 35. This is not what we want. And finally, if P is equals to 29, then X is equals to 49 minus 29 is 13. Yes, this is what we want as well. So it seems to have three situations here. 5, 7, 37, 13, 11, 13, 31, 29, 31, and 13. These situations. Now, the answer is not 3 though, because in each one of the cases, there will be a different number of possible choices of Z. In the first case, where X is 37, P is 5, and Q is 7, how many choices of Z are there? Z just needs to be a prime that is smaller than Q, right? So in fact, I made a mistake here. Z must be smaller than Q, so this one cannot be 0. So Z must be smaller than Q, so it can be only 2, 3, and 5 here. In the second case, where Q is 13, Z must be smaller than 13. That's 2, 3, 5, 7, 11. And then in the last case here, Z must be smaller than 31. So here there's a lot of cases, right? It can be 2, 3, 5, 7, 11, 13, 17, 19, 23, and then 29 are all smaller than the value 31. Okay, so these are the choices that we have. How many cases are there? There are 3 for the first one, 5 for the second one, and then 10 for the last one, a total of 18 cases. And that is our answer. Next question, number 17, we have a speed question. Right. We have 2000 X and Y. They both start traveling from X to Y at 8 a.m. and Alice takes 2 hours 24 minutes while Bob takes 3 hours. Now, Alice turns back walking at the same speed after reaching Y. At what time would Alice and Bob meet? So if they continue walking until they meet, even though Alice turns back, they walk for the same amount of time, right? They walk for the same amount of time, so what that means is that the distance ratio is equals to speed ratio. The speed ratio here is what? So speed ratio here is going to be the opposite of the ratio of time, right? If Alice takes 2 hours 24 minutes and Bob takes 3 hours, the speed ratio actually be opposite way around. The speed ratio will be 3 hours to 2 hours and 24 minutes. Because they take the same amount of distance, they cover the same amount of distance. If they do it in this time, then the reverse of the time ratio is equals to the speed ratio. So 3 hours to 2 hours 24 minutes, do we know what that is? Well, that's 180 minutes to 144 minutes, right? And if you divide that by 36, then actually this is 5 to 4. So the speed ratio is equals to 5 to 4. The distance ratio has also to be 5 to 4. So if you draw out the entire diagram, it means that Alice will go the entire thing, then come back a little bit. This will give you a total of 5 units. Meanwhile, Bob's will go a total of 4 units. Okay, so this is what it looks like here. Okay. So now what's the situation? We know that the entire distance will be actually 4.5 units. Right. So then how can we calculate at what time Alice or Bob will meet? Well, if they travel for 4.5 units, it is going to be what? Sorry, if the entire distance is 4.5 units, this is the usual amount of distance, right? Let's take a look at Bob. Bob travels 4 units out of 4 over 5 units. So what can we say? We can say that Bob takes 8 over 9, right? Which is, this is 4 units over 4.5 units of the usual time. Normally, Bob will travel for 4.5 minutes. That will take him 3 hours. But this time he travels 8 over 9 of the 4.5 units. So this will be 8 over 9 of 3 hours, which we determine is 180 minutes already. This is equals to 160 minutes. So it takes them 160 minutes to meet. That means the time here will be 8 a.m. plus 160 minutes. This is 10:40 a.m. Okay, let's continue. Question number 18. There are two jobs X and Y. For job X, C takes 10 days, D takes 7 days to complete it. For job Y, C takes 16 days and D takes 20 days to complete it. If they can work together or separately, then what's the minimum number of days required to complete both of the jobs? So let's write it down. We will write down per day. So C takes 10 days for the job X. So per day it will be 1 over 10. D takes 7 days for job X, so per day it will be 1 over 7. C takes 16 days for job Y, so per day it will be 1 over 16, and D takes 20 days for job Y, so per day it will be 1 over 20. Now, you want them to work together or separately, so who should do which job? If you notice, the idea is that I want D to do X, and then C to do Y. Why is that the case? Imagine I swap them around. Imagine I don't let D do X, I do C, let C do Y. Then the difference is the difference between these two fractions. We can see that 1 over 7 minus 1 over 20 is actually a bigger fraction than 1 over 10 minus 1 over 16. Right. So what does this mean when you have this kind of fraction difference? That means if I move someone, if I move D to X, and if I move C to Y, overall is a gain in work done. If I move D to X and C to Y, overall is a gain in work done because 1 over 7 minus 1 over 20 is more than 1 over 10 minus 1 over 16. So overall is a gain in work done. And that means that I want D to do X, I want C to do Y. So it firstly takes 7 days for D to finish, right? So 7 days and then D can finish X already. So then C has finished 7 over 16, right? So then in that case it's remaining 9 over 16 of Y, right? Remaining 9 over 16 of Y, how long does it take? Well, we can ask ourselves. Now, for the remaining time, remaining 9 days, I will put D back on job Y. So this remaining now 16 of Y is done by C and D together, right? They will be working together now. So in that case, 9 over 16 will be equals to some X number of days times 1 over 16 plus 1 over 20. How to find X? Where X is the number of days. We can actually multiply throughout by 80, for example. Right? If you multiply by 80, then you get 45 is equals to 1 over 16 times 80 is 5x. 1 over 20 times 80 is 4, so it is 4x. So now you get 9x is equals to 45, so x is actually 5. So it'll take 7 days for D to finish X. Then after that, they will both work on C together. They will both work on Y together. This will take you additional 5 days for them. So the answer is 7 days at the start, 5 days where they work together. This is equals to 12 days to complete both jobs. Okay, question number 19. Question number 19 here. We have this 9-digit number that includes all the digits from 1 to 9, also has the following properties. All square numbers digits are adjacent. What does that mean? That means you have 1, 4, 9. They are all beside each other. Right. Then the sum of the first 6 digits is less than the sum of the last 3 digits. So how can this be possible? Well, 1 to 9 they add up to 45, right? The sum is 45 is the sum. So if you want the last 3 digits to be more than the sum of the first 6 digits, it's either going to be 7, 8, 9 as the last 3 digits, which has sum of 24, or 6, 8, 9. It's either 7, 8, 9 or 6, 8, 9. So now, which is possible? Well, we don't really know. But we do know something. We know that since they must contain the number 9, where must this number 9 be? Number 9 must be right here. Because number 9 must be touching 1 and 4, right? So number 9 must be right here. Now let's take a look at the condition 4. All two consecutive digits cannot both be even or both be odd. So 9 cannot be beside 1. 9 must be beside 4. Right? 9 must be beside 4. And 4 must be beside 1. And using the same reasoning, actually, you can actually figure out on the right side, can it be that this is 8 and 6 or 6 and 8? Cannot, right? Because they are two even digits. So it therefore must be 9, 8, 7 on the right side. Okay, so actually we have the last 5 digits, they're all done already. Yeah. Now, what do we have? We have the digits 2, 3, 5, 6 left over. And then the first 4 digits will be divisible by 16. So firstly, if it's divisible by 16, what can it be? Well, you can end in either 2 or 6, right? And you can end, in fact, if you try 32, 52, let me see, 32, 52, then 60, 36 and 56, they are all multiples of 4. They're all multiples of 4. 32, 52, 36, and 56. Then what do you need to try? You need to continue to try the next one. Right. So we have this is a odd number, even number, odd number, even number. So you can first try a random one. Let's try the number, let's say 236. Is this a multiple of 8 or not? Turns out, no. This is not a multiple of 8. So what is a multiple of 8? 256 is a multiple of 8? Yeah, it is a multiple of 8. Okay. Okay. Now you can check if 256 is a multiple of 8, is 3256 a multiple of 16? Is it a multiple of 16? The answer is no. Because 3200 is divisible by 16, right? But 56 is not multiple of 16. Nope. So these are the cases where you have a 2 in front and a 6 behind. So what if it's a 6 in front and a 2 behind? First, let's try 632. Is this divisible by 8? Turns out yes. Then 652 is not divisible by 8. Okay, so 632 is divisible by 8, 652 is not. Now 632, is 5632 a multiple of 16? I mean, it is the only choice left, right? So it has to be a multiple of 16. Let's check. In fact, it is a multiple of 16 because let me just quickly show you. It's a multiple of 16 here. And then what we have is this 56 divided by 16. That's going to be 32. I mean 3 here. Wait, yeah, no, 3. Sorry, 48. 83 minus of 80. And then here, wait, you cannot really see it. Let me scroll down, sorry. 83 minus of 80, this is equals to 3, then 32 divided by 16 is 2. So this is a multiple of 16. So therefore we know, actually, the part behind here must be actually the value 5632, right, part in front. Now, what is the remainder when this number is divided by 7? Well, for dividing by 7, there's a divisibility rule, right? Hopefully that you remember. Is to cut up into blocks of 3 at a time. Then start from the back. So the remainder, when divided by 7, is you start 987 minus 214 plus 563. You cut it this way, and then you give you the remainder when divided by 7. So here, 987 minus 214, let's do a working in the middle before I add 563. Let's do something here first. This is going to be 377, right? 773 plus 563. Again, let's go and calculate out this thing here. This is 6, this is 3, this is 1, 3. Okay, 1, 2, 3, 6. Now 1, 2, 3, 6, let's divide by 7. 1, 3, 3, 6 divided by 7 here. I can minus off a 7. 63 divided by 7 is a 9, exactly. And then the remainder is just going to be 6. So therefore, the answer for this question is 6. Okay, so that's question number 19. Now for question number 20, we didn't have time to actually type it out within here yet. So let me just quickly type it out as the question at the back of the worksheet. Then after that, we'll do this together. Let me just create a new page. So for this question number 20, what we have is the following. Wait, let me see if actually I have the file that has the question number 20. Give me a while. Let me check if I have the version of the question 20 here. Let me see. If I have, then I'll just share that screen instead of this one. Oh yeah, I do have it. But let me just let me see if I can do anything to it. That okay, I'll paste it here instead. This is our question number 20. And there's a little bit of inaccuracy within this question. So let me just change some things first. So this condition is going to be at least 4 red balls. So let me change it to red. And then there's at least 1 black. And then they want to find the number of black balls. So it's just changing the ball colors around. This is also black, not blue. So this is the question. Okay. So there are a total of 60 black and red balls in the bag. And when put into 6 boxes of 10 balls each, one box will have at least 4 red balls. And when put into 3 boxes of 20 each box will have at least 1 black ball. Find the number of black balls. Okay, let's start from the second condition. Because second condition is a bit stronger. Instead of saying each box, it has instead of saying one box, it has each box. So if put in 3 boxes of 20 balls each, right? Each box will have at least 1 black ball. Wait, let me see. One ball with at least 4 red balls. Okay. Let me see if I can if I understood the question correctly. Just give me a moment. Okay, so let's take a look at the second condition. Second condition says when put into 3 boxes of 20 balls each box will have at least 1 black. Let me see what this means. Okay, I understand what this means now. Okay, so this question, there's a hidden meaning in the question that is not immediately apparent from the English choice of words that we use. Uh, so what it means is that, let me type it out, then you can understand. When we anyhow put into 6 boxes of 10 balls, we can guarantee, this is a very important condition, you can guarantee one box with at least 4 red. So it means that no matter how I put the balls, 6 boxes or 10 balls inside, I can guarantee at least one box with at least 4 red. So in that case, that must be better than the worst case scenario, right? Because the worst case scenario is what? Worst case scenario is that I have these 6 boxes, right? I have 3 red here, 3 red here, 3 red here, 3 red, 3 red, and then 3 red. This is the worst case scenario. So if this is the worst case scenario, we can guarantee one box with at least 4 red. It means that it must be better than 18 red colored balls. So it must be at least 19 red colored balls, right? Because it needs to be better than the worst case scenario. Then let's take a look at the other condition. The other condition says when we anyhow put into 3 boxes of 20 balls, right, we can guarantee at each box we have at least one black ball. All boxes have at least one black. Yeah. So in this case, what's the worst case scenario for the black? Or in other words, what's the maximum? What's the minimum number of red? Well, let me see. Okay, so yeah, in this case, again, let's take a look at worst case scenario. Worst case scenario is when what? Is when all the red go into one single box. Right? It's like that. When all the red go into one single box. If all the red goes into that one single box, it must still have at least one black. Right? So even if all the reds go into one box, there's still at least one black here. What does it actually tell you? If there are boxes of 20 balls, then here in the first box, if I put every single red color inside, the red color must be at most 19 in fact. Right, the worst case is when you put all the red color into one single box, but even in that case, there's at least one black, so the red color is at most 19. Suddenly, we can see the red color is exactly 19, and that means the black color is exactly equals to 41, and that's the answer. Yeah, so therefore, there's a solution for this question number 20 right here. Okay, with that, we finish the question. I'll stay back for a while if any of you want to ask anything as well as uh as talk a bit more. Yeah, I noticed typo says that I have a typo. Yeah, you're correct. I have a typo here. Okay, but if you have no questions you want to ask, then feel free to take your leave now. Yeah. Goodbye.